PCl3, two nonmetals. That's phosphorus, trichloride, because I have to signify that the second one has 3. Then, of course, that's hydrogen. That one is also two nonmetals, so phosphorus, trihydride, and HCl only goes by its proper name, especially when it's in solution. Hydrochloric acid. Okay, next balancing. I'm going to do the hydrogens last because they appear in too many places. So I'm going to do the chlorides. They appear only in 2 places, but compared to the phosphorus, they have more atoms. So here are 3 chlorides on the right hand side. There's only 1 so far, so I'm going to put a 3. And that means I'm going to put a 1 over here. Okay, chlorides are okay. I have 1 phosphorus here and another 1 phosphorus over here. So that matches. And now on the right hand side I have 3 hydrogens and another 3 hydrogens. That's 6 hydrogens. And these are 2 hydrogens. Since they're even on both sides, I don't have to change anything. So I have 6 hydrogens on the right. I have 2 so far on the left. So I'm going to put a 3 there. 3 times 2 matches the 3 plus 3 on the right hand side. Okay, the first one is aluminum oxide. And again, check that aluminum has a fixed ionic charge. So there's only one way that 2 can combine, and it's Al2O3. So when we name it aluminum oxide, there's no question about it. It can only be Al2O3. That, of course, here's hydrochloric acid. This one here is aluminum chloride. And the last one, by its common name, is water. And then we balance. And let's see, I think each of these just appears in 2 places, so I'm going to look for the one that appears the most, and that's the chlorine here. I could also do the oxygen over there. I just choose the chlorine here, so I have 3 chlorines here. That means I also need 3 chlorines over there, and so I have a 1 here. 1 aluminum actually doesn't match the 2 aluminums over there, so I actually do need 2 aluminums right away. Now that matches this one over here. 1 times 2 is 2 times 1, of course, but that way I have upset right away the chlorines, so I have 2 times 3 is 6. That means I also need 6 over here. So 6. And now I'm going to look at the oxygens. I have 3 oxygens over here, and I only have 1 over there, so I have 3 oxygens. I need 3 over here to match the 3 on the other side. And then I have 3 times 2 is 6 hydrogens, and here I also have 6 hydrogens, so on the last one I'm already done. So these coefficients here balance the entire equation. We can check that again. 1 times 2 is 2 aluminums, and here 2 aluminums, 3 oxygens, 3 oxygens, 6 hydrogens, 6 hydrogens, 6 chlorines, and 2 times 3 chlorines is also 6. So here we got CO is cobalt, HgCl2, it's going to be mercury chloride, but mercury has a variable ionic charge, since the chlorine, each one of the chlorines has one negative charge, and there are two, that means they have a total of two negative charges that needs to be matched by the mercury's positive charges. So the mercury needs to have two positive charges, so it's going to be mercury 2 chloride and this one is going to be cobalt chloride, but the cobalt as well has variable ionic charge, and there are three chlorines attached to it, each one of them having one minus, and so that means the cobalt must be 3 plus to match the three chlorines, 1 minus each. So cobalt 3 chloride, and that one is simply mercury. Then we're going to balance, and we're going to, each one of them appears in two places, left to right, that is. So I'm going to start right away with the one that has the most atoms, and that's the chlorines. 3 chlorines here, 2 chlorines there. That means I have to make this one even anyway. So it's going to be 2 times 3 is 6. So therefore 3 times 2 is also 6. That means I have 3 mercuries here. So I need 3 mercuries here. And I have 2 cobalts here. That means I need 2 cobalts here.